All right, folks, so we're going to be reviewing making animations in processing. So last class, we made our little house. We were programming in what's called static mode, which means you just start typing code one line after another, and then processing basically runs those sequentially, and it draws it to, if you use drawing code, it'll draw it to some sort of graphics window, and then it's done. When it gets to the last line, it's done, and you just get to see the output. So that's not great for programs that are going to be interactive, which are the majority of programs that we wrote last year, and will be the almost all the programs we write this year. So we'd like to have a program that maybe you can interact with, or it creates animation, or all sorts of different possibilities. So in order to unlock that, we have to go from static mode to active mode. So I guess I'll start off with my comment. So I'll put in my name, the date, and then review to animation is the topic. And I know everyone here, some people are faster typers and slower typers, so that's fine. Take your time. All right, so active mode. How do we put our sketch into active mode? Does anybody remember what two things you add to a sketch to like kick it into active mode for animation and stuff? Yeah, you got it. Yeah, L says void setup and void draw. And this is, for anyone who hasn't used processing before, I just typed a whole bunch of characters on the screen. It's kind of second nature to us now. Void is a kind of function, which we'll be talking about more. It's kind of a group of code. So all the code that goes from this curly bracket to that curly bracket is what's called the setup function. And then same with draw. Draw is a function, and all the code from this curly brace to this curly brace and everything in between is what belongs inside of the draw function. So the setup and draw function are special built-in functions that processing does special things with. So I'll just remind you about those. And you'll notice that they turned green. Anytime a function name turns green, that means it's a built-in function with special properties, I guess, special times where they run. So we'll be talking more about other special functions later. So setup, this is a function that's run right at the beginning. When you press the little run button, or you press Command R, or however you run your sketch, it runs first and it runs once. So it's great for setting things up, hence the name setup. This is where you will load fonts and create arrays and load pictures and maybe initialize variables and that kind of stuff, which we'll be talking about today. So it's a great place to set up your animations or your games, set lives to 3, set mode to intro, that kind of stuff all goes in the setup. One thing we can guarantee we can put in is going to be size. The size function we'll stick in setup. So I'll say size, we'll do maybe 800 wide and 600 tall. We'll be just randomly choosing those numbers there. Okay, so what's the draw function? So setup runs at the very beginning and only once. Draw is a special function that happens over and over again. It is on a repeat loop, I guess is a good way to put it. And it repeats at a particular rate, which is called the computer's frame rate, which is about 60 times a second. That's what it tries to do anyways. And then processing automatically will adjust that number depending on how much work it's doing inside of each frame. So a frame, 1/60th of a second. That doesn't sound like a lot of time, but for a computer, that's a long time. So it can do a lot. But if you are doing stuff that takes more than 1/60th of a second, then it will slow the frame rate down, and it will call draw less often. You never see that. You don't get to control that. Well, I guess you can control the frame rate. You can make it slower on purpose. But for the most part, you don't have any control over that. It's just this sort of magic function that just happens to repeat over and over again. So it's nice that it does all that for you. If you were programming in pure Java, you would have to write that loop yourself and manage the frame rate and all this kind of stuff. I guess there's libraries that do that as well, but for the most part, it's very nice that processing has given us this feature. So what kind of stuff do you put in draw? Well, you can put a circle inside a draw and see what it looks like. So I'm going to go ahead and put a circle in the center of the screen. Circle. Center of the screen, I just divide my width and height by 2. So it'll be at 400, 300. And to keep the pattern going, I'll make it a 200 diameter circle. So just stick that information in there. Maybe I'll spruce it up a bit. Just to review from last day, I'll give it a stroke weight of 5. And maybe I'll make it red circle. Stroke 255.00. So these are all functions we've talked about from last class. If they don't look familiar to you, you might want to go back and watch the video from last class. Or just talk to me. Okay, so I'll run this and we'll behold our amazing animation. Ta-da! Wait, it's not moving. It's not doing anything. Well, it kind of is. It's getting redrawn over and over again, 60 times a second. So that's nice, but we haven't told it to move or change in any way. So how do we do that? The answer is, as it is right now, if this is all you knew about processing, what we talked about in day 1, and now, we wouldn't be able to animate because these numbers can't change. So instead of coding our arguments as pure numbers, instead we can use a variable. You got it. You can make a variable. Just like in math, you can have like a variable that represents an unknown number. Same kind of idea, except that it's not usually unknown. It might be unknown at any given time, but you can create a variable to hold a number. And the nice thing about variables, it's built right into their name. They can vary. You can change their values. You can't change 400. 400 is exactly 400 at all times. But if I made an x variable, then it could change over and over and over again. I could change its value. So let's do that. So where do you make variables? There's actually more than one place, but for the most part, last year, we went above the setup function. Remember this little space up here? We call that the global variable space. It's also a place to put comments as well, but I'll put in global variables. Now, what is a global variable? We didn't have much time to look into global variables versus local variables last year. And I kind of just like slid it in every once in a while. I made an int in draw instead of up here. So we probably won't talk about that too much today. But keep that in the back of your mind, because in the future I'll bring that topic up about what other kind of variables other than global variables are there. And in general, programmers tend to try to make fewer global variables because every part of the code can change them. So if something goes wrong with a global variable, it's hard to know where is the problem happening. It could be anywhere. But these other kind of variables, local variables, for example, they can only change in a particular place, so it really helps you to narrow down the errors. So let's make a variable. So I'm going to make a variable to control the x coordinate of my circle. So the way you make a variable is you first choose the type. And your choices are int, float, and boolean. And that's not entirely true. There's more choices. But these are all the choices we needed last year in terms of what are called primitive variables. We also found that there's other kind of variables you can create, but these are the main ones we're going to use. An int is for making integers, so numbers with no decimal component. 47, 0, negative 19, those kind of numbers. Float is for decimal numbers, like 0.5 or negative 132.6. And then Boolean is true and false variables. So they're just true or they're false. No other possible value. So let's start off by making an int. So the way you make a variable is you first choose the type. So in my case, int, and then you give it a name. So I'll say x. And you can give it a value right now if you want, like, 400, and then semicolon, or you could leave that blank, and you could choose to do that in setup. Some people like to separate those two things. But I'll leave it up to you to decide how you want to do that. I'll just say x equals 400 for now. And once you've made a variable, you can stick that variable anywhere that expects an int. So you can put it, for example, inside of an argument for a function. So I can stick my x right here in the circle function. So if I run that, Well, we still don't have animation, but it didn't break anything, so that's a positive. How come it's not changing? How come the circle's not moving? Well, because x isn't changing. We still have x equals 400 every frame. It's always 400, 400, 400. So how do we change it? Well, we can use assignment operators to change a value. We can assign it a new value. So for example, could be anywhere in the draw function, but I'll just go underneath the circle. I'll say something like this: x equals x plus 1, semicolon. I'll just pause to make sure everyone can write that down, and then I'll talk a bit about this, because if you would put that in math class, well, I can see this being a question in math class. It would be like, what is the domain of this equation? Or something like that. You know, ever get those questions like, what is the range and domain of this function? This would be like, there's no number. Like, there's no real numbers that can satisfy this equation. So that's one of those trick questions. Because usually, domain is all real numbers. There's no numbers that satisfy this. There's no number that equals itself plus 1, right? 99 does not equal 100. And the story behind this is the equal sign is not a math operator in the same way that you would see in an equation in your math class. This is what's called the assignment operator. So I'm going to write that here. Equals is assignment operator. What it's doing is it's assigning x the value of x plus 1. So that's an important thing to remember from last year. Do you remember how you do check if two things are equal? What was the way we did that? Yeah, Tommy. Yeah, two equal signs. Now we would say equals equals, which is kind of sounds weird, right? Comparison operator is the name for that, whereas this is the assignment operator. But we all understand equals equals as well, so that's good. Yeah, if you wanted to check if two things are equal, you use two equal signs, which is all sorts of awkward and so easy to make that mistake. I remember many of you last year, looking for like, where's the problem in my code? And it would be like if, and then in the if statement you use a single equal sign. And we all just kind of scratched our heads like, oh, Java, processing, why did you make it so hard? But yeah, it's equals is the assignment operator. So what we're going to say is, whatever x was, it's going to be whatever it currently is plus 1. So if we run this, we'll see it goes from 400 to 401 to 402, and it just keeps doing that over and over again. So if I run it, let's see what it looks like. Behold, it is a circle. What? Why is it getting longer? That seems strange. And it's just going to keep on going. Bye. It's gone. It's going out the window pretty soon. It's going to go to Mr. Harris's room and all sorts of stuff. It's going to be good. So what happened? Well, first of all, this streak that's left behind tells us something interesting about active mode. And that is that each frame is just drawn on top of the last frame. So it doesn't erase the frames. And that's kind of fun because that might be something you want to do. You might want to make that feature happen, right? That might be a good thing. But oftentimes in animation, it's not. You don't actually want that to be trailing behind there. Could you imagine playing League of Legends and they didn't clear the screen? Like it just the streaks of your characters all over the place. Like it's hard enough game as it is. So how do we get rid of it? Well, you can manually paint over the last layer at the beginning of the draw function. So at the beginning of the draw function, instead of just start drawing stuff, you could cover it with a big rectangle, or you could use the background function, which, by the way, is poorly named. It doesn't draw in the background. It just covers the screen with a color. So background's kind of a bad name, but oh well, we're stuck with it. So background. Oh man, I felt so bad last year. So many backgrounds or backgound. It's I don't know. It's a hard one to spell. So just check it out and see if you spelled it right. I don't know why it's highlighting my stroke weight. Oh, it's not the stroke weight, it's the background. Okay, so I'll keep on going. So here you just put in a color. I'll make background 0, just for funsies. You can make it whatever colors you want. So now it'll clear the screen by filling it with black, and then it will draw the new things. And that's going to create animation, because it's going to clear it from one frame to the next. And it now just looks like the circle is majestically sliding across the screen, right? Our brains can't distinguish that from just motion, because our eye and our nervous system its refresh rate is too slow to see the difference. I know people make a big deal about gaming monitors that are like higher than 60 frames a second. Like what's like the best refresh rate on a monitor?
Right now, like the highest you can go, like the best for your eyes.
What is it? What's the highest?
Highest, I think it's like 400 now.
Yeah, it's like really high, right? But what are the advantages of that? I actually don't know.
I mean, like, I'm pretty sure most of our eyes can only see up to like 240. So like,
Yeah.
that is like
No, I don't even think it's 240. Like television is only like 20 some frames. 20. Anybody in media arts? Like film and television is like 20 some frames per second, and like that's been great for every movie I've ever seen. Oh, thanks.
24.
24. Thank you. So I don't know what advantages a game has in terms of visual. Yeah, thanks, Alexander.
I think it's usually for like pro players who want to react to things really.
like a 60 frame monitor versus a 144. Like, there's a noticeable difference.
Is there? Well, I'll have to check it out. I don't actually know the difference, so I will endeavor to see it. Okay. It's probably a different games too where it matters more than others.
Point of diminishing.
Diminishing returns. Totally understand. Sounds like pro gaming. Spend 10 times the amount of money for like 1% better the whatever thing. But hey, that can be worthwhile when you're competing against people who are when that 1% is all you really need to get the edge. So cool, that's good to know. But hey, our 60 frames per second is all processing can muster, and I think that's going to be plenty good for any game that we're going to create this year. So, but I wonder if you ran that animation on a monitor with a higher frame rate, because you can actually change the frame rate. If I said frame rate, is it capital R? Yeah, frame rate with a capital R. You can set it. You can set it to 240 or 400. I don't think my screen will support this, so it'll automatically knock it back down. But you could do this and change it and see what the difference is, and if there's a difference, I don't know. We'll see. Probably not too much on our processing game.
I mean, doesn't like games and stuff, like they can hit higher frame rates, it's just that you won't see the difference.
Yeah, for sure. So, yeah, hard to say. Anyways, we'll move on to our next thing here. So we got our circle. Looks great. We got some variables changing. What are some other things we can do? Well, guess what? We don't have to just add. We can also subtract. So we'll just list all the different kind of operators we have. So we have adding, looks the same as adding. Subtracting looks the same as subtracting. So that's good. If we subtract, what happens? If I put a subtract x equals x minus 1, what do we see? Carson, yeah, we go the other way, right? So it's decreasing the x value of the x variable. So we can see that going the other way. Great. There's also multiplying, which is the asterisk. And multiplying we didn't use really for animation because it will look stupid. Like timesing by 1 is, first of all, not going to change anything. But we could do 1.01. That might be fun. Oh, except it's an int, so I'll have to change it to be a float. So just give me a second here. You don't have to do this. I'll just change x to a float. You can leave it the way it is. I just want to demonstrate multiplying as if you haven't seen multiplying before. And whoop, it didn't really accelerate that fast, hey? Let's do 1.1. That's going to compound real quick. Whoa! So you can see that this kind of thing isn't great for multiplying, but we definitely used multiplying last year for some of the more complicated stuff, like checking if two circles were colliding, right? So we could multiply or divide to change those values. So we have multiplying is the star, dividing is the /. And there's one other one we used, which was very mysterious, and I think we'll use more this year. The %, which was pronounced mod or modulus. It's kind of funny because modulus is what my kids are learning in grade 4 right now. And you all know what it does. It gets the remainder in a division question. So for example, if you were to do, let's see, what's a question my son did last night? We have the Kumon math workbooks. We don't actually go to Kumon because I'm a math teacher, so I'm like, I'll just save myself the money and we'll just do it at home. And then I just set the timers and we go through the stuff. I don't know. They probably hate it. Actually, they kind of don't hate it. They kind of don't mind it because I guess we kind of make it fun. But anyways, yesterday we did remainder for the first time, and I thought, oh, it's so cool. This is what my students are doing in Programming 12. So I made sure to hype it up, and they were like so excited to be like, whoa, we're doing this crazy thing. It's not that crazy, is it? Like, for example, if you did, let's see, 66 divided by, I don't think I can do divide sign, but I'll do it that way, divided by 9. Right? 66 divided by 9. Well, you could get a decimal answer, but if we're just talking about integers, well, 9 goes into 66 7 times, and then what's the remainder? 3, yeah, remainder 3, and then Kumon, you probably wrote it like this, 7R3. That's how I'm telling my kids how to write it, that kind of stuff. So, do you get why it's remainder 3? Everyone kind of remember how to divide? Yeah? Great. So, guess what? If you do modulus, it just gives you the remainder. If you do divide, it just gives you the quotient. If they're integers. It'll actually kind of separate those into two different things. So sometimes you want the remainder and sometimes you want the quotient. So it depends which one you use. If the variable is a float though, it will just do division the way you expect it to. It'll be like 6.333 or whatever the answer is. So this only applies to integers when you're doing math with integers. Does anyone remember when we used this modulus thing? There's like one thing at the end of the course we did with it. It was trying to see if a number was an even number or an odd number. So if we wanted to see if a number was even or odd, we divide it by 2 and get the remainder. If the remainder was 0, it must be an even number. So and we used it actually to slow down animated GIFs too. So we made it only go every 3rd frame or every 10th frame or something like that. So we use modulus for those kind of things. So you don't need to know too much about modulus today, but just know that it exists, and we'll go over it again. It's nothing fancy. It's just grade 4 math, at least in the Canadian curriculum it's grade 4, and it just gets the remainder instead of the quotient. That's it. That's all it is. So I'm going to put this back to being an int. I see the sun's kind of shining on your computers there, hey, guys? Feel free to close the blinds, because I can tell that's going to be uncomfortable and hard to do anything. And that goes for the whole year. Always feel free to change these blinds. Also, these blinds, if anyone wants to close them, please feel free to do so. All right. One thing while we're here, I'll just mention, I think you've already noticed, but decimal numbers like floats and ints don't mix together very well. Like if I try to add 0.5, it doesn't like it because now x is an int. So adding a half to an int means it won't be an int anymore. So it won't let you do that. So be careful about mixing things that are ints and floats. Okay, that's about all I wanted to say about the operators, the math operators. We'll get into more interesting math operations later on when we look at colliding circles and those kind of things. So now I'd like to talk about making decisions in an animation. So we can make our circle go across the screen, and now it's heading off to Mr. Harris's room. But what if we wanted it to come back? So in our animation project, we learned about using if statements. If statements allow a program to make a decision. We started off with just a regular if statement. Later on, we learned about if else. And then at the end, well, in the middle of the course, we learned about if else if when we did the mode framework. So we'll just talk about if today. And it's a way of making a decision. I'm going to erase this, this division here. So an if statement works the following way. You say if, and then in parentheses, you put a true or false question. And if the question's answer is true, then the code inside of these braces will run. If the answer is false, the code inside of these braces will not run. So it's basically a way of choosing, do I run this code or do I not run this code? And the conditions will probably use comparison operators. So these are the assignment operators here. If statements use comparison operators. So for example, when you want to compare two numbers, you might use the double equals, or we just call that comparison. So that's to see if two numbers are equal. You might use greater than or less than. You might use greater than or equal to or less than or equal to. And I think that's probably all the ones we used last year. So you can see if two numbers are equal, greater, less than, etc. And you can put those into the brackets of the if statement. So let's say I wanted to check to see if the circle had gone off the screen. I could say, hey, if x. Now, there's a bunch of different things you could say here. We're going up by 1, so we could just choose the exact number. So we could say if x equals whatever number we want. We'll say 800. And then what do we want to have happen? Well, we want it to wrap around again, so then we'll use the assignment operator to give it a new value. We'll say something like x equals 0. It won't do this all the time. It'll just do it when that's true. So that's the difference between comparison operators and assignment operators. And the if statement, you can see, if statement is doing nothing, it's 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 doing nothing, and bam, all of a sudden it finally does something. At that one moment where the center of the circle hit the edge of the screen, when x equals 800, finally its moment has come, and it's like, aha! And it's just like, I imagine, no offense to percussionists here, but like the person in the orchestra with the triangle, ready to like hit the triangle at that moment when it's their turn. Like, it's so good. And it just continues otherwise. It's still moving in that direction. Nothing really fancy is happening. But eventually it'll happen again. And now it just jumps over to that point. So the if statement means you can run lines of code at specific times or under certain circumstances. All right. What if we were going up by, say, 3, though? Ooh. We could get into a problem. Check this out. It's going to go a lot faster. And it doesn't ever come back. Why? Hey, why? What happened? Yes, Tommy. Yeah, if you take 400 and you add 3's, you won't get to exactly 800, right? So, oh, that sucks. So what do we do? Well, we could just say greater or equal to 800. Or you could like figure out what that number is and say equals like 803 or whatever. But this is kind of a little more convenient because then I can just play with this number however I want to. I can try 5s, I can try 9s, I can try whatever. And this if statement will still eventually become true. So using something like a greater than comparison operator is sometimes more flexible. It doesn't require you to know exactly the future of that circle's location. So this should work better. Here it goes. Woohoo! Yeah, notice that the speed changes, right? I think everyone will remember from last year, but if you weren't here last year, we're increasing the x value by a larger amount. That translates into speed in the animation. It looks faster because it's moving more pixels every frame. Okay, so how are people doing out there? This is all familiar? Feeling like old news? Good, and hopefully not too fast for people who are new. I think, given that we have just 15 minutes left, and I think I'd like to just come around and say hi to folks and also just see how new people are doing, either new to the course or if you've never taken Programming 11, just to check in on that. Let's stop new content, and we'll just say this will be our chance for you to make your own fun animation. You know what? In hindsight, I should have thought of a cool animation to make. Because circles are pretty dull. I had thought of a cool animation, but I was expecting to do custom functions. So we're going to make like a face move across the screen. But we don't want to do that until we've reviewed that. Any suggestions out there? Anything we should make go across the screen? Or animate in some way? Thanks. Yeah, that's so good! Trisha, I love it! Let's animate our house. So you could copy and paste. I think everyone has a house, except for, well, yeah, Mickey, you're new to the class, so just work on your house probably, and then you could jump in and do some animation with it. So yeah, we'll animate our house. Some people have already done it, so that's going to be really nice. But add something else to it. And by the way, it doesn't have to be, like, the obvious thing that comes to mind is, like, the sun is rising behind my house. It's going up in the sky. But feel free to do something else. Feel free to, oh my gosh, I live by the PNE. and like our house is shaking every night with like I don't know what band is playing, but their bass is maxed out. My house is shaking. So you can make your like, I don't know, it might be hard to make that rectangle grow and shrink, but that might be fun. Something you might want to consider is, how would you make something, instead of the sun just going up and then like coming back around, how would you make it like bounce off the top and back down? That'll preview next class's lesson. So if you're looking for a bit of a challenge, you can make the sun like bounce off the top or something like that. Well, yeah, animate your house in some way. A sun and maybe a moon is a really cool idea. You can also make smoke come out of the chimney if you want to draw a quick chimney. You know, it doesn't have to be like elaborate smoke. Just be a circle smoke, a rectangle for smoke. I don't know. Gandalf like blew a whole ship of smoke in the Lord of the Rings like that. So I'm not going to judge your smoke ring or whatever it is. So yeah, take your house and add some animation to it. And I'll come around and just say hi to folks and check out how people are doing, okay? I'll stop the video. Thanks for watching if you're watching. Bye.